Hello. So in this video, I want to look at understanding where the distance formula comes from, and hopefully once you see it, you're like, oh, and now I don't have to really memorize it. And there's a lot of proofs out there where people prove this, but I don't see a lot of people using actual concrete values first. It's usually in terms of abstract x's and y's, so I will go into that, but I wanted to at least springboard from something that you can see and understand. I know some people don't like all that abstraction. So the idea is this: the distance formula, if you have 2 points and you want to find what is the distance between them, the shortest distance is a straight line. So there's the distance that you want between 2 points. The thing is, how do you find that? Well, what you do is you superimpose like an imaginary vertical and horizontal line here. Oops, that could sure be a lot better. To where you have a vertical line and a horizontal line coming together, and of course that creates a right angle, right? And so as soon as you have a triangle that is a right triangle because it has a right angle in it, now you can invoke the Pythagorean theorem. And so the Pythagorean theorem, of course, says that a squared plus b squared equals c squared, so that the sum of the squares of each of the shorter sides of the triangle, of the right triangle, is equal to the square of the longest side of the triangle, right? So you can invoke that because of this right here, right? Pythagorean theorem only applies to right triangles. So when you do that, let's go ahead and do that with some actual values so you can see it. Let's say I want to find this d here, and let's say this is 7, 4, and maybe this is 9, 12, and you want to find what is the distance between that. So what you would do is you'd say, okay, I'm going to create this imaginary right triangle, and I would like to find, I don't know this distance, but if I could find the distance or the length of each of the legs of the right triangle, then by the Pythagorean theorem I could square them and add them, and then and then take the square root, and I'd have the distance, right? And I'm finding a and b. So you're like, okay, well, how do I do that? Well, what you realize is that since this is a horizontal line, this point here must be at the same level, right? These 2 points are at the same level like this. So that means if this is at a height of 4, this is also going to be at a height of 4. And then the same thing is true here. You know, horizontally, this point is underneath this one, so it must be at the same horizontal position, so it must be have a x coordinate of 9. So now you're like, oh, okay. So now I can say, well, now how do I find these lengths? And you're like, well, okay, for this horizontal one, these 2 points are on the same horizontal line, which is really y equals 4. Then the only change is in the horizontal distance. So from 7 to 9. So from 7 to 9, what's the distance? Well, you just subtract them, right? You do 9 minus 7 equals 2. So basically, use a different color here, this distance is 2. You do the same thing here, and you're like, well, the only change between this point and this point is a vertical change. There's no horizontal change because they're have the same x coordinate. So then all you have to do is say, oh, well, that's 12 minus 4, which is 8. And so you're like, okay, so that distance is what? 8. So now if you looked at it like we had here, where you could say, and it doesn't matter if this is A and B, or you could also, and C is always across from the right angle, or you could have also said this is B and this is A. That part doesn't matter. C is always across from the right angle though. So what you would then say was, okay, let's say that's A squared, that's B, that's A, that's B, and this is C. Then you'd say, okay, invoking A squared plus B squared equals C squared, you'd say 2 squared plus 8 squared is equal to D squared. And then, although you could already do the arithmetic, one thing that's going to happen here is you're going to take the square root here, right? So you're going to end up taking the square root of d squared and the square root of this, right? So now you have d equals the square root of 2 squared plus 8 squared, which of course we could do. That's going to be what 2 squared is. Let me get on a different paper. Let's go here. 2 squared plus 8 squared is equal to d. Take the square root of all this. So you have the square root of 4 plus 64. And now you have the square root of 68. So there's your answer. That's your distance. Now, if we go back and see here, what actually formed this, the side of this A was formed by subtracting these two x values. So what they'll do, let's do this in abstract form. What they'll do is say, hey, here's 2 points. And if we superimpose now the horizontal and vertical lines, now they'll call this a general x1, y1, where the 1 is the same subscript because it's for the first point, P1, for example. And then they'll say, oh, if we call this point 2, this is going to be x2, y2. And now if you go ahead and apply the same thinking that we had where we're like, hey, these 2 points are at the same horizontal distance, right? So this is going to be what? The only change here is going to be horizontally, but not vertically. So this point will have to have y1 as its y coordinate, and then looking vertically, since these two points have the same horizontal position, this has got to be x2, and they only differ in their vertical. So now, if you apply the same thought process, you're like, well, how do I find the change or the distance here? Well, it's just like we did here. We do 9 minus 7, but now they're just abstract points, and you say, oh, well, this is A, the side A, if I call this, and side B, is equal to x2 minus x1. And this B, this length, is the difference in the y coordinates, so B is y2 minus y1. But we know that A squared plus B squared is equal to C squared, and we'll call this D. So here we know A is x2 minus x1, and then we want to square it. B is y2 minus y1, square it is equal to D squared. And now you're going to take the square root of both sides, right? So now D is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay? So there is the hopefully understanding of the distance formula, right, that you normally see here. And hopefully now what you could always do is you could always draw this and just think about it and say, hey, what are the coordinates of this point right here, which is the intersection of the vertical and horizontal line that creates this right triangle, so that I can apply the Pythagorean theorem. And once you create these two coordinates just by visually seeing, oh yeah, same level on the y, here, same level on the x, you can find these two coordinates, and then you're just finding this, you're subtracting the x coordinates here and subtracting the y coordinates here to find the lengths, and then applying the Pythagorean theorem. All right, thanks so much for listening.